This is the session 5 of the U.S.-India Water Pumping Partnership. My name is Craig Overmiller, and today we're going to be talking about horizontal water pumping. We've already talked about our power supply system that we put together. We've talked about our vertical water pumping, just getting it up out of the ground and getting it into a cistern. You don't necessarily have to have a cistern. You can have what's called an on-demand pump, so that whenever you open a faucet or anything like that, the pump sees a low pressure, and so it automatically turns on and starts pumping water. And that's one of the things that an option that you have. So with the horizontal water pumping, we start at the cistern. So we had talked about the cistern before. And we also talked about, you can put that cistern, up in the air about 15 feet. And so the cistern has an outlet at the bottom and it has an inlet at the top. The inlet is going to be 1 inch, and the outlet is usually 1.5 inches or 1 1/4 inches. You'll be using millimeters there in India. And the cistern has a set amount of water reserve in it. And so you can build pressure 2 different ways. The whole idea of the horizontal system is this is where we create our pressure to push water laterally or horizontally. And so we have to look at our end users, whether it's going to be livestock or if it's going to be humans or people. And so we got to determine how we want to treat that water. But anyway, with the cistern, we're going to go ahead and treat the water inside the cistern, and we're going to have an ozonator. An ozonator creates 3 oxygen atoms, and the 3 oxygen atoms bond together, and because of that, it robs all the organisms that are in that water of oxygen. And so hopefully they all die, and that's the idea. And so coming out of this outlet, one of the very first things you're going to want is a valve. You want to be able to turn this off if possible. Another thing I'm going to add to my particular cistern, which I'll show you, when we get out to the job site, I actually want to add a T. The water quality in my location is really, really bad. And so I want to put a T in there. And then what I want to do is put in a sand filter and pump. Sand filter and pump. And then it just pumps right back up into the top of the tank and back in. And then this has a discharge on it so that you can clean out all the sediment and everything that you got caught in there just with this discharge. It's a really good, simple system for clean filtering. Actually, all it does is it's not going to purify, it's just going to filter the water that's inside there. We're actually just going to use an inline filter, which is pretty simple, just a little cartridge filter. So we'll use a cartridge filter. To purify our water. I mean, not to purify it, but to clarify our water. Now then, we're gonna be coming along, and we're gonna go straight into a pump. So we're gonna go, see if I can remember what symbol of a pump looks like. You know, we have the inlet side of the pump and we have the outlet side. And so this is going to be a pressure pump. Some people call it a lateral pump. The whole idea of the pressure pump is to pressurize a pressure tank. And so we come out of the pressure pump, and then we're going to go to a pressure tank. Now then, the particular pressure tank that we have can get to 150 psi. The particular pressure pump that we have can get to 60 psi. And this is, I'm pretty sure I looked it up, and this is a 24-volt DC pressure pump. Now then, the pressure pump says that it's preset at 60 psi. So it may or may not need a pressure switch. And so what happens is we have a pressure switch. If we do need a pressure switch, it will go right there. The purpose of the pressure switch is to see what pressure is inside the pressure tank. And so if the pressure drops below a preset, which is usually around 30 to 40 psi, it sends a signal. The pump tells it to turn on. So the pressure switch, remember that control board we had, the solar panels? So we have our solar panels up here. We can't get away from these guys. So we have our solar panels. And they're feeding the batteries. We have our batteries again. So we have our solar panels, we have our batteries, and we have our power and control. This is our power and control board. Power and control board is where we bring in all our power and we regulate everything that's being done in our water pumping system, whether it's our vertical pumping system or our horizontal pumping system. Right now, we're talking about horizontal. So we have this guy right here. And so we have our DC distribution and AC distribution. So we're going to have both DC and AC distribution panels. And so this, I believe, is all DC. And so we'll be coming, the solar panels will be charging the batteries will come up and handle the load. There'll be the line side for the load on our DC distribution. And then from here, it goes down to the pressure switch. And the pressure switch will then come up and power the pump. So we have a signal and we have energy. All right. So we'll wire those up. We'll look at how it goes together. I'll verify this right here. So my job is to verify whether or not we need a separate pressure switch. I'm thinking what they're trying to tell me is this is good up to 60 psi. And so I'm thinking I have to have a pressure switch. If I do a pressure switch, we'll probably do one that is a 30-50. So what that means is a 30-50 pressure switch. If the pressure inside this tank drops to 30, it will trip the switch. The switch then will tell the pump to turn on, and then the pump won't turn off until we got 50 psi inside this pressure tank. And so another thing that this is nice too, not only is it, I think it's 100 gallons. We'll look on the label just to be sure. And we'll verify that in the field. So I'm pretty sure it's 100 gallons. And so then that pressure tank then goes to a manifold. That manifold will have several different outlets. And each outlet will have a valve. And so those valves, and this will determine if we're going to go to potable, which would be potable, which would be community water. It can go to surface water, irrigation, or it can go to livestock. Make sure everything's on there. Yeah. So surface would be irrigation for crops. So we can set a manifold, and then that manifold can take care of all these different items right there. Now then, one of the things that we have on this board, and it has to do with this guy over here, and that's this O3 system that we have. We're going to do two different types of O3 systems. We're going to do a pre-bought one, and then we're going to do one where we actually make it ourselves. So the ones that we make ourselves, I've got all the parts for it, and we'll have to be very careful with these UV tubes. If you touch them with your fingers, they're probably going to be ruined. Plus, we're going to have to use some very special type of stainless steel, and then particular ABS fittings, and then we have to use what's called butyl sealant. UV cannot get through butyl, and so UV is very dangerous. It's like an acid, and eventually it will eat everything up. So you got to be real careful on the materials that we use. And so all the materials that I picked for this particular system that we're going to build is all, nothing's UV proof, but it's UV resistant. And so on the board, we're going to have our UV system. Now our UV system has to have AC power. And from our previous design, we have the inverter, and the inverter is going to be powering our AC distribution panel. So we're going to be using this for our tools, and we're going to be powering our UV system for our water purification. And so from our UV, it'll come across and go into the top of our tank and down through our tank and into our UV. It's kind of like an aerator. It just pumps the UV into the water and dissipates not the UV, the ozone through all the water, and so that it purifies it real well. And then also we have the option, we have, an inlet up here. We can drop chlorine in here. So very important, keep that water pure, keep it where it's good and safe for everybody. Also, I like Here again, this is our pressure tank, so it'll be on a platform. And this one too, it doesn't have to be in the air. If it's in the air, it'll have gravity feed. And just remember, water is very, very heavy. And so you can get some pretty good PSI, pounds per square inch. You don't use pounds, but your measurement, you guys know what it is. And you can get some pretty good pressure just by pushing this thing up into the air. Like I said, we're going to have this pressure tank down here. It can go up to 150. We're not going to get that high. We're going to probably get around. We're probably only going to get to 50. We'll use a 30-50 switch to turn the pump on and off, and to get our pressure. Now then, this will probably be used in 1 1/4 inch. And it'll be PVC piping. So everything we'll be using on the outlet side of our horizontal water pumping system will be PVC, Schedule 40. That's good for 130 PSI. And we're never going to get to 130 PSI. You can see right here when we'll get to 50. And so, and it's really easy to put together. It's all going to be slip joint and glue. So you can just run with it. You can splice it, tie into it. You can come in and tie into it anywhere. Just put a T in, put a valve, so you isolation valve. I always recommend isolation valves anywhere along the system, so that you can add things. And so it makes your life real easy. You definitely want to make sure you got this valve right here as you come out of your outlet, so you can turn things on and off. And then also on the sand filter, you want to make sure you got valves so that you can cut this valve off, but you're probably going to want to put a valve here. Excuse me. Probably going to want to put a valve here and here so that you can take it out of the system if you need to take it out and clean it. Those sand filters, you'll need to take out, clean, and redo. I'll show you what a sand filter looks like. I've got one on a big surface tank that purifies that tank, and you'll see how it works and pumps water and keeps everything nice and clean. You'll see these a lot of times on swimming pools, but they're very, very good at keeping your cistern or your storage tank clean. The reason again for the cistern for your horizontal pumping is if you ever have to take the pump, work on the pump, the actual pump. Now, one of the things we talked about, we have the pump, and it's way down inside the casing. We've got our pump sitting way down here, and we got our water level up here. You want to make sure you got plenty of distance from the bottom of the pump to the bottom of the casing, so that the water, so sediment can get down in here and not get inside your pump. Sediment is your enemy when it comes to your submersible pump. Over here on this pressure pump or your lateral pump, you can easily take that out of line and clean it. Here again, you want to make sure isolation valve, so that you can take things apart, work on them. Wouldn't hurt to have another valve here. And we'll look at all these different valves that we have. Another valve right here. You know me. I gotta have my valves so we can isolate everything. The pressure pump works on a diaphragm. It has a diaphragm right here, and so water fills up in here, and this is air. It compresses the air. And the air is what pushes back down on this diaphragm. It's like a rubber diaphragm. And it pushes back down on it to create the pressure that we're looking for. And it'll maintain that pressure. Here's another reason why you want the pressure tank. Because you don't want this pressure pump running all the time. And so you pressurize 100 gallons, you got 100 gallons. As soon as you run out of the 100 gallons, you get down to 30 psi, pressure pump kicks back on. It limits the time that the pump is running. And one of the things you want to try and do is, let me get that cursor, I'm sorry. One of the things you want to do is limit the amount of time that your pumps are running, even over here. Now, I had talked about where you can do a demand pump. So there could be a demand pump down here. It can come up and out of the ground, and it can go right in to your horizontal system. You don't even need the cistern. I would recommend the cistern. The reason I recommend it is for reserve and for purification and filtering. Okay. But what you can, anytime something opens down here, you open any one of these valves down here, this demand pump will come on. And if you have the demand pump, you don't need the pressure pump. All right. So anytime it sees low pressure on the demand pump, that pump's going to kick on and send water to this manifold. You can eliminate this and eliminate the pressure tank too. You may want to keep the pressure tank, even though there's a, I've seen lots of times, in fact, on every single demand pump, I still see the pressure tank. So there's a lot of different options. The one we're going to be using is going to be the regular submersible pump. Going to be a submersible pump inside our casing, and it's going to push up and go into the cistern. So we're going to be using this particular system is what we're going to be installing when we go out to the job site. And so that's pretty much everything that we have there. You can add more control systems to our board up here. In fact, we probably are going to have some other things up here. I know we have a lot of different disconnects that are going to be put in just because we want to save everything. And then also, the one thing I keep talking about is we will have a ground rod. That we will be installing on this system, because you do not want to be the ground. It ruins your day. And so both the DC and the AC system will be bonded, and they both will go to this particular ground rod. We have an 8-foot ground rod, and we have the tools for putting it into the earth. And so it's also called earth ground. And so all that is what you want to have. So horizontal pumping is actually pretty easy. This is where all the weight is. Getting that water up out of the ground and into the cistern. And then once we get to the cistern, the weight of the water itself will help. One of the things I do is along this line here, I come in and I put in a valve. And I put in where you can connect a hose. And then just from the weight of this water here, if all this goes, all of a sudden decides it doesn't want to work anymore, you can just open this valve right here, just like this one. Open this valve right here. It's attached to a hose, and you can just take water wherever you need it. Or you can bring buckets. You can bring, whatever you need, and fill up water, and you have treated water. So you're in good shape at that point. So you always want to make sure you have a way to get water. And we'll make sure we put one of these in so that you can see what I'm talking about. And I want to make sure I take a picture of this before I leave today. And then we'll use this as, both of these we're going to be using as our designs when we get out to the job site. And so the session 4, the one just before this with vertical drilling, and then this one is horizontal drilling. You can see it's pretty easy and everything goes pretty well. And it's just knowing all the different parts. There's a lot of fittings that go in here. There's a lot of male, female, there's couplings, there's adapters, there's compression fittings, there's threaded fittings, and then there's a lot of electrical that's going to be going on in here. So we have to make sure that we have all the electrical connectors we're going to need and all the electrical safety devices that we're going to need. Because I want to make sure I put a 120 volt, 20 amp plug at this location so that we can use our power tools. We're going to have our cordless tools out there, and then we're going to have a whole lot of hand tools. And so you want to make sure you have all these with you. Another thing we'll show you when we're on the job site tomorrow is you want a multimeter, and I don't have one with me right now, but a multimeter that is a clamp meter. And I'll show you what that is. You have to be able to do not only AC amps with that clamp meter, but you need to make sure you have a DC clamp meter. You want to know what the amps are going through those different conductors. You want to make sure that the conductor you're using is capable of handling the amps that are going through it. So if you got a number 10, that's good for 30 amps, and then all of a sudden you put a clamp meter on it and it says it's 50 amps, you better upsize that conductor. You would have to go back and check it. And also with an AC DC clamp meter, before you turn any of these components on or any of the devices on, you can make sure that continuity is good, there's no shorts, and then also to be able to check all your voltages to make sure the voltages are the proper voltages. Most important thing is the polarity. When we're doing with working with DC, AC, polarity, it doesn't really seem to matter that much. But with DC, you better make sure that polarity is correct, because you're going to get one chance with DC. And then that equipment's going to be damaged. And so we have to be really, really careful when we start putting these different components together. And so I'm thinking that's pretty much everything. Let me walk over here. We look at it from a different direction. Whenever I look at it from a different direction, I see something different that I need to talk about. And it looks like we're still pretty good. The different types of filters again, we have the big sand filter here, or we're going to be using a cartridge filter for our system. Like I said, you can use a demand pump, but we're going to use a regular pump that's going to work off of our up in here. Remember, we have a float switch that tells this pump when to come on. So that's how we do that. I like this system because it has built-in pressure, and it also, if the pump goes bad, you got a reserve, and then you also have pressure to push that reserve. So that's one of the good things of having a cistern, and I think that's pretty much everything. I can't think of anything else. I think everything that we have here is pretty much solid. And then we'll look at, when it goes to livestock, we've got some big tanks that we use, surface tanks. Here's for irrigation. Now, if you do surface irrigation, sometimes you'll need an additional pump in irrigation, what's called an irrigation pump. So you may want to use an irrigation pump. I got that cursor right on my head. And so, and then if you go to potable water, that's pretty easy. You're just going to go to a community system where you're running into water, and then that water is going throughout the community, and it's going to the different homes, businesses, things like that, community bathrooms, whatever needs water. And so that's what is nice about the system. And we'll look at making manifolds. Manifolds are real easy. All it is a bunch of T's. You take a bigger piece of pipe with a bunch of T's on it, and you put a bunch of reducers in it, you got yourself a manifold. And so they're not hard to build. And we'll look at all the different things. The pressure switch, we'll just make sure we got one that works well with our system. And I think everything else is pretty good. Pressure switch, it's like pressure comes on and pressure goes off. It opens and closes, depending on what the pressure is on the system. And Like I said, remember, ground rod, ground. Gotta make sure we have all of that. And then we'll do the two different types of UV systems. And you'll really like the one which we build ourselves. I like it because I just kind of took it and designed it from some other systems that I saw. And it's really easy. It's very expensive though. It's still just the material alone to build a UV system, an ozonated system. The material is $300. That's American dollars. And so that'd be different from I can't remember your monetary system. But everything is pretty easy, pretty simple. We'll go out on the job site and then we'll start looking at all these different parts and start putting them together. And then we'll, like we said, we got three systems, actually three different systems, or three different systems that we're going to be building. We're going to be building the vertical system, the horizontal system, and then the control board system, power and control system. So those are the three systems that we're going to have in this water pumping system that we're going to be building together as a joint project. So I think that covers everything for the last segment. And then, like I said, tomorrow, depending on the rain, if it's raining, I'll just put up a tent. We'll just work underneath the tent. And then, or if it's sunshine, I'll put up the tent so that we're in the shade. And if we have our inverter up and running, we can even put in a fan to keep us cool. So I'll get a fan that pulls a little bit of, not a whole lot of electricity, so that we can run it for quite some time just off the solar panels. All right, so once again, I enjoyed it. Glad you all could be here today, and see you all tomorrow out on the job site. So take care, and we'll see you tomorrow. I'll leave that. Let me get out of the way. All right, so I'll leave that right there. You can look at that, and then you can see what it looks like, and pause the YouTube video and study our line diagram that we created. So this is actually a line diagram of what we're going to be doing. So y'all have a good one, and hopefully it's not raining where you're at. Take care, and I'll go ahead and end this meeting.